In this video, we will practice using the distributive property in several chemistry problems. Robbie studies a particular gas held within a piston cylinder system. The gas expands from an unknown initial volume to a final volume of 0.05 cubic meters at a constant pressure of 3 pascals. If the work done by the gas is 0.09 joules, what was the initial volume of the gas? The work of the gas is found by multiplying the pressure by the change in volume. We can replace the pressure in the equation for 3 pascals and multiply this by the change in volume, 0.05 cubic meters minus VI. All this equals to 0.09 joules. We will rewrite this equation as 3 times 0.05 plus negative VI equals 0.09 to keep track of the negative signs. Use the distributive property to calculate the initial volume. We multiply 3 by 0.05 to get 0.15, and then 3 by negative VI to get negative 3 VI. We leave the plus sign in the middle. 0.15 plus negative 3 VI equals 0.09. Subtracting both sides by 0.15, we can cancel out the 0.15 from the right of the equal sign, and on the left, we know that 0.09 minus 0.15 equals negative 0.06. Lastly, we will divide negative 3 from both sides to get an initial volume of 0.02 cubic meters. Suddenly, the gas further expands from 0.05 cubic meters to an unknown value, but the pressure is now increased to 10 pascals. If the work done by the gas in this step is 0.2 joules, what is the final volume? How do we set up our equation? Yes, if our work equation is work equals pressure times change in volume, we can substitute our known values to find pressure. It looks like 0.2 equals 10 times Vf minus 0.05. Try this one on your own. Use the distributive property to find the final volume. Nice! The final volume is 0.07 cubic meters. Now, let's look at a trickier word problem that involves a bit more understanding of the situation. Rebecca is 21 years old, and she is of age to have 500 milliliters of vodka with 50% alcohol by volume, ABV. However, it's too strong for her, and she dilutes it to 25% ABV. How much water did she add? Originally, Rebecca has a mix of alcohol and water in the 500 milliliters. If we know that 50% of this mixture is alcohol, how many milliliters of alcohol is in the mixture? That's right, it's 250 milliliters. We take the 500 milliliter mixture and multiply it by 0.50, which is our 50% ABV, to get 250 milliliters of alcohol. The amount of alcohol doesn't change from the original to the diluted solution because we are only adding water to dilute the 500 milliliters. Therefore, the 250 milliliters of alcohol will not change. Though the alcohol does not change, what does change when we add more water? Exactly. Let's look at a diagram to understand what's going on when we add more water to the original 500 milliliters. We will name the unknown amount of water added as X. When we add X amount of water to get our diluted 25% ABV, what does our total volume expression look like? Yes, we have a total volume of 500 plus X milliliters. Since we know that this diluted mixture is 25% ABV, we know that the fraction of the milliliter of alcohol over the milliliters of alcohol and water times 100 equals the ABV. So our total equation now looks like this. 250 milliliters of alcohol divided by 500 plus X milliliters of alcohol and water, all times 100 equals 25. Now we can just solve it. What is our first step to solving this equation? We want to divide 25 by 100 first because we can't solve anything within the parentheses. Yet the 100 is being multiplied by the whole left side, so we can divide it by the whole right side first. This leaves us with 250 divided by 500 plus X equals 0.25. We still can't do anything within the parentheses, but we can multiply both sides by 500 plus X, leaving us with 250 equals 0.25 times 500 plus X. To get rid of the parentheses, use the distributive property to solve 0.25 times 500 plus x. We will multiply the 0.25 by 500 to get 125. Keep the plus sign and then multiply 0.25 by x, which is 0.25x. We're almost done. What is x, which is the amount of water added to dilute the original 500 milliliters? Exactly. We will subtract both sides by 125 to get the constants alone, giving us the equation 125 equals 0.25x. Finally, we divide both sides by 0.25 to get x alone. Our final answer is 500 milliliters. Rebecca added another 500 milliliters to her original 500 milliliters. Dilution is very common in chemistry, so we can control the amount of concentration precisely for experiments, as well as keep us safe since some chemicals can be highly concentrated and hazardous to handle.